Good morning, good afternoon, or good evening, wherever you are in the world. My name is Martin, and hopefully we'll be together for the next hour at this DPS presentation on T-SQL window functions. So, window functions have been in the product since 2005. They were a much requested feature prior to that, and the product team obviously listened to that feedback and thought it would be a great idea to introduce them into the product. They're an anti-standard feature, so they've obviously in other relational database, other competing products, and SQL Server thought it would be a great idea to introduce them, and they've added a lot of value to the product. So over the course of the next hour, we're going to walk through a collection of demos. We're going to see some innovative ways, or I think innovative ways of using them. I use them a lot to track down errors and to use them for set-based processing to replace maybe row-by-row processing. And we'll see an example of that at the end also. But just as a way to introduce myself, because I'll be hiding down in the bottom corner for most of the presentation, down I think this corner, I'll just make myself big for a minute and just talk. So this is what it is. It's a virtual presentation, and I guess that's got pros and cons. It couldn't go out to a wider audience, but obviously people aren't there in the classroom alongside the presenter. Now, I was lucky enough to be over at Data Platform Summit in 2019. I had a fantastic time, and I thoroughly recommend it to anyone watching who wants a trip to India, obviously at a more convenient time in the world when airline flights are back on. We're back to basically living a normal life again. But last year I learned a lot. I went to a lot of sessions, I met a lot of speakers, I met a lot of attendees, a lot of the volunteers who make the session a great place to visit. But also out in the wider community. I went to some great restaurants, seen the traffic. The traffic is amazing, something a little bit different. We don't have traffic like that in Brisbane, Australia at all. Visited some great temples and some great history and that sort of thing. It was fantastic, and I would love to have been there again. In fact, I had actually planned to be at DPS in 2020. Unfortunately, that wasn't to be. So maybe 2021 we can be back over there, and hope to see you there. So for the rest of the presentation, I'm going to go through some demos, some slides, some that sort of thing. I'm going to be hiding over here in the corner. If I am in people's way, I'll move, but essentially I'll be here. So I might put my glasses on so I can do the presentation. Go back to hiding in the corner. I might even turn my camera angle around to face the screen and have fun. Let's get into it. So, first of all, we'll take a bit of a sneak peek in what we're going to look at for the rest of this hour together. So, our agenda coming up. We're going to start off with some of the more basic features of window functions, and that's the ranking functions. Although these are basic, they've got a lot of power, and you can use them for more than just putting numbers on a result set. There's so much more you can do with them than just that. So we're going to have a look at that, some of the ways I've used them to help me track down errors in data sets. We're then going to move on to some more advanced functions, look at totaling, making this easier than perhaps it was in the past. And then we're going to look at accessing rows within the data set. So we don't have to use a cursor to do row by row processing. We can simply move forward a row or back a row, or forward 5 rows or back 5, whatever we choose to do, but accessing different rows rather than the current row in a data set without resorting to row-based processing. And finally, we're just going to have a look at an example where I'm going to take something that was once a row-based processing algorithm and bring it inside SQL Server, and we're going to look at transforming that into a window-based function so it can be done all in one go rather than using a set-based approach, which might take longer and have all sorts of problems. And that's it basically. We're going to explore some other things along the way. We'll maybe have a look at some other T-SQL concepts, but essentially we're going to stick to the format of window functions, and hopefully we will all learn something. So let's take a look at some of the important points that I'd like to get across from this presentation. The first one really is that order in a data set is important. I guess it seems quite obvious. For example, if we just do a select query on a normal data set and we don't put an order by clause on, we can't guarantee the order that the rows are going to come back in. We might think we can, and it might look like it always comes back in one particular order, but essentially, unless we put an order by clause on any result set we're getting back from SQL Server, we can't rely on the order whatsoever. And order is particularly important with these window functions. Another thing that I'd like to get across is the concept of frames. So these are called window functions, and that's essentially because there's a window across the result set. So if we think of a traditional single result set we get back, we might have a frame around that window. Now, the frame doesn't really matter in that case because there's one single result set. But what if we want to break that result set down into 2 or 3 or 4 separate result sets, kind of partitioning it, if you were? Well, we can do that with window functions, and it's quite straightforward. Again, we're going to need the order by clause, and we're going to need something called a partition clause as well. So, as well as the order, frames are particularly important. And the general flow of this presentation is basically going to be example, example, example. So we're going to run over maybe a slide or two, and then we're going to get straight into it and run through the examples, and hopefully, like they say, a picture's worth 1,000 words. Hopefully an example will rather get the point across rather than just watching slides for the entire time. So it's an examples-based session, and I hope you enjoy it. And so here we see a pictorial example of what I was talking about in the previous slide. We've got a single result set, basically select all from sysObjects and the top 20 odd rows. And around it we've got a single frame which we've actually defined. And so that might lead you to think, well, isn't a frame the same as a result set? And in this particular slide, it looks very, very similar. But one of the things we can do with frames that we can't really do with result sets, so to speak, is start manipulating them differently and accessing different rows within them frame, or summing, or doing aggregates, or things like that. So let's contrast this single standard result set with still a single standard result set, but with multiple frames around that result set. And here we can see the same query, select star from sysObjects, but here we've divided the rows into 4. So the top frame in blue has got 6 rows. The frame below that in orange has got 3 rows. 9 rows in the frame below that, the green one, and 2 rows in the final frame. And you might notice that the row number that we've placed in on the left hand side starts at 1 and goes down to 6 or 3 or 9 or whatever the case is within each frame. And then the next frame it starts again, and the next frame it starts again. And basically we've accomplished this with window functions. So we've essentially put window frames inside the wider result set. And that's going to allow us to do other things to those frames and the data within those frames, more manipulation, accessing of rows, and that sort of thing. So I just put those up as a pictorial representation of what we're going to look at throughout the rest of the demos. Because from here on in, we're probably going to feature quite a few demos, which hopefully will get a lot of these points across in a possibly more intuitive way. But anyway, let's dive into them and see how it goes. Plenty of time for questions towards. And so all the scripts for the demos we're going to see are available in my GitHub repository. This first script that we're looking at will actually restore the database that you can work with, although you don't have to. any data that I need to apply, and I put 3 Excel spreadsheets or CSV files in the repository, and so you'll have that all available. The only thing you'll have to do in here is change the path to the backup file, and all you need to do is press Ctrl-Shift-N, change the path if you like, press OK, and you're sorted. You can restore the database, back up the database if you make any changes, basically do anything you like. So let's have a look at our first proper demo. So let's dive into our first piece of code, and the purpose of this is really just to create a table with a number of rows that we can use going forward in some of our subsequent examples. The main purpose of it is to demonstrate order and order by. And order by is such a fundamental concept of relational databases and SQL Server in general that a lot of people, especially when they're starting off, don't understand the importance of order by and might think that it's irrelevant. But like I said previously, if we want to guarantee the order that things come back in, we need to put an order by clause in. So I'm just going to generate a table of numbers, and I'm going to use some code here that's probably can be found in a lot of places on the internet, a recursive CTA. Brings up an important point here, well, a bit of an aside to Windows functions, but CTEs don't necessarily need to start, well, they don't need to start with a semicolon. We see lots of these on the internet starting with semicolons. That's not actually needed. What is needed is if there's a statement immediately prior to this, that statement must finish with a semicolon. And that's because the with statement can be used in a number of different places. And so obviously the SQL Server engine needs to determine if it's being used as part of a CTE or not. But anyway, this is going to generate us 65,000 rows. I've commented out the last row, otherwise if I did put that in, we'd end up getting a lot of rows back, and we don't actually need that many. However, this does introduce us to the first of our window functions, and that's the row number. And all row number does is it brings back a sequential list of numbers, and obviously we're making use of that here in a numbers table to bring back a sequential list of numbers. We'll notice that it's got an over clause, which is fundamental to window functions in general, and that over clause has an order by. So running that, we'll see that we'll get back 65,000 rows. Now, in order to demonstrate a bit more of what we said about order by, I'm just going to throw all of those rows into a table, and I'm going to order with a modulus of 6. I just want it to bring the rows back in not a sequential order. It's not really a random order, this just something that isn't sequential. So let's do that. Let's throw them all into a table. And let's do our first select statement without an order by clause. So when we run this statement, we can see that the order they come back in is really, well, there doesn't seem any real order to it. We'll scroll through, there's 65,000 rows there. There's no real order to how SQL Server's brought them back. Now, if we just put a clustered index on those rows and run that statement again, we will see that the order will be slightly different. And that's two identical statements we've run, both without an order by clause, yet we've got the order of the rows back completely differently both times. So let's drop that index again and do another select statement. And again, we've got a different order. Let's put a clustered index on there, but this time in descending order, and see what effect that has on the order of our columns, or our column in this case. So we'll select there, and we'll see that this time the order that it comes back in is decreasing. following the clustered index. So I guess what we can say there is that, SQL Server will just find the easiest way it can to bring back the data if we don't put an order by clause on there. Well, obviously it'll find the easiest way regardless, but if we don't have an order by clause, SQL Server will just order it in the way that it sees fit, and majority of the time that might be according to how it got the data through the clustered index or a different kind of index. Okay, but going forward we don't need 65,000 rows in our table, so let's just delete approximately 64,000 of them and keep about 1,000 rows. See what kind of counts we've got in there, and I think in this table we've got 1,000 rows ranging from about 65,500 down to 64,000, and the reason I've put a range that big in is so it doesn't actually get confused with what we're going to generate in the following examples. So here we see the first of many window functions we'll look at, and that's the row number. Sequentially puts a number on each row of the data set, and the vast majority of these window functions all follow the same format. A row number, a window function, in this case row number, followed by an over clause, and inside the over clause a method of telling the function how to order the data. In this case it is just an order by statement, but we'll see other syntax shortly. And that basically is it. So we'll run that statement, and traditionally an order by a column ordinal would be allowed in a SQL statement. However, that is not allowed inside a window function. What we can do, if we don't have a particular column to order by, we can use syntax similar to this, which is basically a select statement inside the order by statement, and that works perfectly. So that's basically all there is to the row number function, just bringing back a result set and putting a sequential number onto each row. But the order by clause, has it got any connection with the actual order by clause of the main SQL statements? And the answer to that is a resounding no. Here we see we've ordered the row number, and we're just calling it row number in the alias, in a descending fashion, whereas we've ordered the actual complete data set in an ascending fashion. So we see that the rows in the digit column are ever increasing, while the rows in the row number column are ever decreasing. So the two order by statements, although part of the main statement itself, are totally independent of each other. And we can have more than one window function within the main statement. Here we're seeing a row number that's one is ordered ascending, the other is ordered descending, and that's perfectly fine. Here we've introduced a third column, and that's again another row number, but ordered in a random fashion with new ID. Basically, I go in, brings it back in a random order, and that's perfectly fine too. Now, obviously, all the numbers start at 1, so if we want to change that, we might have to do a little bit of maths. Take 1 away if we want a 0-based start, which we may well do in some instance. If we want to increase by more than 1, 2, 3, 4, all we need to do is multiply by the step, and in this case 2, and our rows will be ordered 2, 4, 6, 8, and so on. If we want to start at a particular number, in this case 56, we add that to our row number and obviously decrease by 1 because it's a 1-based data set in the first place. But do something a bit more complicated. Start at a number and increase by another number. In this case, start at 56, increase by 4. But what if we want to do something a little bit more complicated? Raise to the power. So here we're going to raise numbers the power of 2 and raise to the power of 10. So we'll run that and we get back some numbers that probably we're all familiar with, raised to the power of 2. So 2 to the power of 1 is 2, 2 to the power of 2, 4, 2 to the power of 9, 5, 12. And the same with the powers of 10. Now, if you are going to do maths on these functions, you need to do the maths on the entire statement, because you can think of that entire statement as bringing back a single number. So we could have actually put brackets around that. We haven't in this case, but we could have. They wouldn't have made any difference. So why might we want to do maths on one of these functions? It seems a pretty straightforward, almost trivial window function. Well, imagine that we're dynamically generating statements from the database, and we want to ultimately run each one of those statements back into another database, but we want to separate them with a go statement. Now, traditional T-SQL statements, we're going to find that a bit hard, but here, well, basically we're just selecting from sysobjects an object ID. It's just basically for example, so I've got two statements. The first statement actually creates a SQL statement and orders by 1, the default. The second statement adds a go, but the row number increases by 2. So joining these data sets together, we'll get numbers going 1, 2, 3, 4, 5, 6, and there'll be different statements and fit together nicely. So you probably see what I mean when I do run this statement. And we get back the statement and a go, the statement and a go, the statement and a go, the statement and a go. And that can be quite a neat trick in generating statements, either 1 or 2. You can separate by 3, 4, whatever, separated by a go separator. So there we go for that example. So we've seen that in the over clause of window functions, we can put in an order by. Additionally, we can also put in a partition by clause. And what the partition by does is it divides up logically the result set into essentially windows, frames. So here we're using a partition clause. We're basically grabbing a digit and dividing by 5. Obviously, the answer will be some sort of decimal. However, we're only taking the first part of that because it's an integer, and we're using that to kind of group by into the partitions. So let's have a look what happens there. In fact, we've already run it, and we can see that we've got the row number, that the answer that we get when dividing by 5, and there's the digit themselves. So we can see we've got 4, as we'd expect, 4 in the first group, then 5, 5, 5, 5, 5, all the way down, and there we've got the digits. So let's just do something a little bit different, and we'll again divide up by 5, partition, but we'll also randomly order within the group. And this can be useful for things like dividing large groups up into smaller groups, maybe to perform an exercise or something like that. But as we can see here, obviously we've got similar answers to what we did initially, but the digits are kind of randomized. Might be a little easier to see if we order by something or partition by kind of the alphabet. Maybe that's a bit easier to see than numbers. So let's do that with our sysobjects. Partition by the first letter of the object name, and we can see there 1 for C, 1 for D, and then we get down to F. We've got 2 there in the partition. Ones get down to P. We've got a whole load of objects beginning with P, Q, and so on. So basically that is how we use the partition clause in an overby clause of the window function. For the next example, I've decided to use a list of countries, basically because I think looking at lists with alphabetical characters in is maybe a little bit easier than looking at numbers in. So we see our list there. I actually put a row number on it already, full of countries. So what we should be able to do is to find the 15th country in our list. So let's have a look at that. And we'll see that we're unable to do that because SQL says, well, window functions can't be used in the where clause. So we are a bit stuck. So how to get around that? Well, we do have a couple of alternatives. Obviously, we can do things like put them into temp tables or table variables or things like that. What I chose to do is just select from a result set that we've previously created. So I basically got a nested select statement there, and I'm just going to look for the 15th country in the list, and I find it. And that's absolutely fine. Now, we've seen row numbering order in a descending and an ascending order, and that can be sometimes really useful when maybe we want to verify that we've got the inverse of an order by. For example, we're ordering by ascending and descending. Now, in this example I've got here, obviously that's quite obvious because I'm ordering by country ascending in one and country descending in another. And we can see that in this particular result set, there's 241 rows. So if we add the ascending row number and a descending row number, we should get basically 241 plus 1, so 242. And we can see going down the list that that's exactly what we get. These all add up to 242. So as a check, what we can say is there anything in that result set that doesn't add up to the count of the result set plus 1. So in this case, we've ordered a simple ordering ascending and descending. We expect nothing to come back here. So let's have a look. And in fact, we do get a whole lot of results returned, which we weren't expecting. And that's because some of the countries do in fact appear in there twice. Because they've got administrative capitals and legislative capitals, judicial capitals, basically different kinds of capitals. So if we do want to make sure we've got the inverse of our order by clause, we will have to go a little further. So in our order by clause here, we're obviously ordering by country, then capital city, and then capital city type. And then we've got the complete reverse where we're getting our descending row number. So this time we should get 0 and 0 rows returned from our result set. And indeed we do. So I do kind of find that a good way of getting the inverse of an order by clause, and especially when you've got complicated order by clauses or ascending, descending, and you want to reverse them all. So finding like almost a reciprocal of the order by, this is a great way to do that. So next we're going to introduce the rank function, which you might look at the list and think that it's identical to the row number function. For example, we've got identical numbers up the top, and if we scroll all the way down to the bottom, we also have identical numbers, which might lead to the conclusion that they're exactly the same. However, if we look where we have a tie, we can see that row numbers carried on sequentially, whereas rank has actually got duplicates, and the number after that continues as though the duplicate had never occurred. Now we might want that behavior, or we may not want that behavior at all. But there's another function that acts slightly differently, and that's called dense rank. So let's have a look at those 3 window functions alongside each other. And we can see that if we go down to our duplicate row again, both rank and dense rank have tied the countries at number 22. But whereas rank has moved on to number 24, which is the same as row number, dense rank has just moved on to the number after 22, which in this case is 23. So if we scroll right down to the bottom, we can see that we've accounted for quite a few duplicates in our result set. Row number and rank have the same value. Dense rank has got a value that's a little bit different. So let's put those all together and join and put a partition clause on there and see how they react to that. And basically we can see that where we've got a tie, both rank and dense rank just reflect that with a 1 in the partition, whereas row number has actually got the number in there. Let's take that a little bit further, and we'll see that if we do order by something that is completely unique, they actually all react the same, and we'll see the same numbers around here. Our tie is no longer a tie because we put in extra columns that make it unique, and they're the same down the bottom. So using that information, we can actually say, well, could we use these window functions to identify duplicates? And yep, we can definitely do that. We can look at our row numbers simply and equate where it equals to. So as we know, we can't put window functions in the order by clause, so we just do basically our nested select, and we can see there that we've got a whole load of duplicates. So that's rank and dense rank. Very similar but subtly different, accounting for ties, where they move on to the next number or move on to the next number, accounting for the ties. So to just round out the ranking functions, the final one is entile. Now, entile I've never found to be a tremendously useful function, but what it does is it takes a result set and it will divide it up into a number of groups that you specify. So here we're dividing our country's result set, which has got 241 rows, into 14 groups. And obviously 14 doesn't go exactly, so we're going to end up with 3 groups where we've got 18 rows and 11 groups that have got 17 rows. The only real question I've got about this function is what happens if you specify a number that's greater than the number of rows you've got. So let's have a look at putting like 350 in or something like that, and it does an error. It basically everything's got one row is in one group, and there's less groups than we actually asked for. So if you do use this, make sure you've got some sort of check-in to verify that the number of groups is the same or less than what you've asked for. So I just wanted to take a quick minute and look at a real world problem that I used the ranking functions to solve. So in front of us we've got a spreadsheet that basically contains sporting fixtures, and the sporting fixtures involve 2 teams, but here they're listed kind of away, home, away, home, away, home, in that pattern throughout the spreadsheet. And I was told that this spreadsheet was arranged manually by an individual, and there was no real natural order to the spreadsheet, but this ordering or this type of spreadsheet came in pretty regularly and had to import it into a database and do stuff with it. So I could have put on an order number in Excel, but we didn't choose to do that. So let's flick over to Management Studio and have a look how I did this. So initially I had to import it into the database, which I did with a bulk insert statement. And then we kind of decided that, well, the game date, the round and the place actually makes this unique. And the tiebreaker, so to speak, would be the home or away. So if we ordered it in that fashion, it'd actually be ordered fine. And if we run that statement there, we can probably roughly say that the results that we get back looks very similar, if not identical, to the original spreadsheet. So we then kind of figured, okay, well, we've got our row numbers on there. So if I divide through by 2 and get a remainder of 1, then it's a home game. If not, it's an away game. So let's try that. So this should bring back no rows, but in fact it does bring back one row. So now let's look at doing something, well, pretty much the same, but having a remainder of 0, and that should get us away games. So we did that, and we get one result there. So clearly there's something wrong with the spreadsheet, and a bit more investigation into that led us to deduce that they're either in the wrong order, and a bit more investigation led us to the fact that there'd been multiple games at the same venue on the same day. So this wasn't really an option. We had to go back to the client and discuss this with them. So we went back to the client and asked them if they could add something to actually make it unique, which was indeed the time. So now the combination of the game date, the game time, and the place made it totally unique, with home and away being the splitter. So knowing that fact and using the same strategy as previously, dividing through by 2 and taking the remainder, we could set up a home games table and an away games table, and then simply join the 2. Now obviously there's other ways you can do that other than with row numbers and ranking and other things like that we use, but that is one example where row numbers came in really handy for myself. Now let's move on and look at some more window functions that are not ranking. So let's look at the same problem we had last time, not in as much detail. And one other way we could have solved that with window functions is to use the lag and lead functions. And what they actually do is give us access to the row before or the row after, or 4 rows before, 4 rows after, or whatever number we choose before or after the current row. So I've got a query here with 4 columns at the end, where 2 of them I'm going to look at the lagging column, lagged by 1 or lagged by 2, and the 2 columns at the end I'm going to look at the leading column, so lead by 1 and lead by 2. So let's have a look at that, and we can see that this is the column we're taking as our base column. The first column is lagging by 1. So when we've got the first column, we're obviously not lagging by anything, so there's a null in there. But with the second column, we're lagging by 1, and so the column up here is what we're actually displaying. In the next column, we obviously can't lag by 2 here because there's no 2 columns above, but the column below is, which is column row 3, is in fact row 1 here. And the inverse with the lead function. So what is leading in the column here? So we're leading, we've got away is over here, and 2 rows below it we've got home, and that's the pattern that follows all the way down. Now clearly we could have probably used something like that in here. We'll just go back and briefly look at those lag and lead functions, and we can see that they take the form that we've looked at previously with the function. Here we take an argument, the column we're looking at, and the number either behind or in front that we want to that we're interested in. But in the over clause, we're listing the order by that we want to be able to look at the lag and lead function. And in this particular case, I've got the same order by clause in all 4 statements here, which is how I've come to the result of this data set. However, notice that I haven't partitioned these into groups of 2. So when we're looking down, we're just continually looking down or looking up. We're not taking into consideration the groupings in twos. So let's pause and have a look at that. You'll notice that in the original query, the one we've just done, we've got some nulls up the top, and that's basically because in the first row we're saying what was above it, and obviously there was nothing above it, so we get a null. What were the two above it? Obviously there's nothing above it, so we get two nulls. And in exactly the same way it happens down at bottom, we're saying what's the row below? There isn't one, so we get a null. Or what are two rows below? There aren't any, so we get a null. So we actually want to eliminate that sort of thing, and we do actually want to just look at the sets and go, what's a home game, get the away game, what's the away game, get the home game. And we can do that by using a case statement. And so all we do is we say, if we're looking at an away game, then look what we're lagging and get the row 1 that we're lagging. Or if we're a home game, look what's leading by 1 and grab that. And so if we run this statement now, what we'll see is, because we're no longer, say, in the first row it's really obvious, we're not looking what was the row before. We're just now, because it's home, we're looking what is the row immediately after, and it's away. And when we hit away, we're saying what is the row immediately before, and it's a home. So we eliminate the null in there, and we obviously eliminate all the nulls down the bottom. And because we are actually using the partition function in the over clause, we've kind of broke the result set down into pairs, and then for each pair we're just saying we've got the home game, so look what the away game is. For the away game, look and see what the home game was. And using the lag and lead functions there, we can access the different rows in the data set without using anything like a cursor or resulting to any kind of row-based processing. One of the things that window functions makes it easy to do is sum, running totals, things like that. And we can use different T-SQL methods to accomplish the same thing, but it might be a little more difficult. So for this example, I'm just going to construct a table of about 12 values with some random numbers in. And just as a little aside here, I've constructed these numbers using the rand function. You'll notice that when I've used rand on its own, I basically essentially got the same number back multiple times. However, when I've put put a seed in there, check some new ID, you'll notice it is and obviously multiplied it by 100 to 2 decimal places. Those numbers there appear very, very random, and if I run that again, I will in fact get some brand new random numbers. Now I don't need the rand column for our example, so I'll just take it out and create the table with one column in. And all we're going to do is basically sum that column using our window functions. So first of all, let's have a look how we do that if we were using a traditional T-SQL, and it is definitely possible. One of the ways we can do it is we'd do an inner join back on itself, group and order by. So let's see that, and what we should see is a running total of the 12 numbers that we've got in the table, and indeed we do. Perfectly correct answer. Now if we wanted to put the actual original number next to the running total, we can obviously do that too using traditional T-SQL, not window functions at all. So let's have a look at that. Yep, there we've got our numbers, and in this column here we've got our running totals. So obviously we can accomplish this without the use of window functions at all. But do window functions make it easier? Well, we've seen that statement there is getting on for 21 lines, whereas the statement here, the window function statement here, is basically 6 lines, and we've used a sum. However, we've got an over clause, and we've ordered by the values that we intend to, of the order we intend to sum in. So let's have a look at that. And that's probably the equivalent of the original T-SQL we've seen, where we just got one column running total. Now, if we do want to see the original values next to the summing value, next to the running total, obviously all we have to do is add them in. So that's reasonably simple to see. Obviously our original numbers there and our running totals in the column next to it. And so what we'll look at here is summing those values in an ascending order and a descending order in the same result set. And all we need to do is again use the sum function with an over clause specifying an ascending direction when we want the direction to be downwards, and when we want the direction to be upwards. Again, in the over clause of sum, we'll just specify a descending direction. So let's have a look at that. And there we see this is running continually counting upwards, and this is continually counting downwards. Here we see a very similar thing, but all we're adding in is a random direction, and obviously, like we've seen in other examples, ordering with the new ID. So they'll see the same result as in the last demonstration, but obviously a new column added here in a random order. Obviously you wouldn't do that in real life, but if you needed to for some demonstration reason or whatever, you could do that, no problem. So that's basically the running totals using window functions with the sum keyword. And so to round out the session, I wanted to look at using some of the skills we've acquired and gone over to solve a real world problem that previously was solved using a row by row approach using SSIS. And here you see a file in front of us that basically contains locations on a system. There's 3 types of different locations. There's a computer, a directory, and a file. And files fall within directories, and directories fall within computers. And I just need to put an ID on them. So I've actually imported that into SQL Server. And we can go away and have a look at that here. And so what I actually want to do, for every time I hit a computer, I want to increment an ID, a computer ID. So I want to put on this a computer ID, a directory ID, and a file ID. So every time a computer changes, I want to increment the computer ID. Every time a directory changes within a computer, I want to increment the directory ID. And every time a file changes within a directory, I want to increment the directory ID. And as we'll see, there's a number of computers, directories, and files within the data set there. We've got 3 computers. We've actually got a whole heap of files as well, and directories. We'll have a look at them. Probably too many to actually show on the screen, but we've got lots of directories within a computer, and obviously lots of files within a directory. So what would probably be best to explain this is just to look at the finished result, and then we'll look at how we actually achieved that. So what we actually want to do is we've already got a system ID that's already in the data set. We want to put a computer ID on the objects, a directory ID. So if we hit computer, the directory ID will be 0 because obviously it's a computer, it's the first thing we come to, and the file ID will be 02. As we encounter our first directory, we increment the directory count to 1, and the file ID, because it's a directory and not a file, will be 0. And then as we come across files within the directory, we basically increment another counter to go from 1 upwards. And then as soon as we hit the next directory, we increment the directory count and the file count goes back to 0. Let's look at one where we've got a few files. Number 3, the file count starts again from 1. And this was done using row by row processing using SSIS. But we had a good look at this and we found a way to just run over it with a set-based approach using window functions. So let's have a bit more of a look at that. Let's scroll back up and see how we achieved it. So to start off with, I created a brand new table just called computer types new, and I've added 3 columns. I've added a computer ID, a directory, and a file ID. So computer ID, directory ID, file ID, and obviously a case statement to say if it's a computer, set it to 1, if it's a directory, set it to 1, and if it's a file, set it to 1. And that's actually quite important, because how we're going to achieve the sequential summing of the numbers is basically to sum the 1s all the time. So let's place those into a brand new table and let's look at achieving what we need to achieve basically. So let's have a look at the table that we've just created, very similar to the original table with 3 new columns. And so let's start off by incrementing the computer ID, and all we're going to do here is use the function that we previously looked at. We're going to sum the computer ID and we're going to put an over clause and order it by the system ID. So let's have a look at that. And this is just a select statement, so we haven't updated anything there, and we can see as soon as the computer changes, we've incremented number, and as soon as the computer is changed again, we've got lots of stuff in that computer, but as soon as this is changed again to a 3, we've got a computer there. And so this has worked nicely. However, this was just a select statement we did. We need to perform an update statement to update the computer ID column. And yeah, I've got Redgate installed here, so I'll execute that anyway. It's just giving me a warning saying I'm trying to update a complete table without a where clause. Quite a good fail-safe check there. And then we can see we have actually achieved that. In our computer ID column, we've got 1s, 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 2s, 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 and then it's changed to a 3. So the next thing we want to do is something very similar, but we want to increase our directory ID within a computer. And so a very similar concept, but here we've added the partition. So we're actually going to partition by the computer ID. And get our numbers, and so we can see we won't look at all the computers here, just the ones that have started off with. The computer ID is 1 and the directory, the first directory is there, then the directory is changed, the directory is changed again, and as the directory changes the numbers increase slowly. They don't however increase when we encounter a file, they actually stay the same. So let's, we just need to run an update statement to update our directory IDs. Again, Redgate tells me I'm doing an update statement without a where clause. And it's pretty much exactly the same thing to do again, but this time we're going to partition by the computer ID and the directory ID, order by the computer ID and the system ID, and basically that will help to increment the number of the file count. And all we need to do then is basically run a new update statement and update our file IDs, and they will increment within the directory. The directory is obviously incremented within the computer. And so as we looked at previously, we can just go and look at that here, and we will see that that's kind of worked out pretty good with the computers all incremented. The directories incrementing where appropriate, and the file numbers incrementing within the directory, which is incremented within the computer ID. So that, obviously I'll put that together piece by piece. We could put that in one complete statement if we wanted. But the conclusion is that that actually runs far faster than some row by row processing, especially if the file is quite large. So yeah, that brings us to the end of our demos. And so I just thought I'd round out the session by pointing you at different ways you can go about exploring more functionality within window functions. And we can see that there are a whole load of functions available. We've literally covered all the ranking functions. We looked at some. Obviously there are more aggregate and analytical functions, and interestingly enough, the next value for, which is often used in defining a sequence, gets a mention here. But there are additional things we can do inside the over clause. For example, around here we'll see syntax that refers to the preceding row or the following row or the current row. And these are very similar to how we looked at the row above or the row below or the lagging or leading rows. And so they would definitely help in extending our knowledge. We can look at range and rows and also between, which are additional functions that can be used to manipulate the frames of the windows. So I hope you can basically just have a read of that document. It's not the longest document in the world, so that'll take 15 minutes to read. It'll probably take maybe a bit shorter. But the over clause is pretty fundamental, as we've seen, to the vast majority of Windows functions. So have a look, have a read, and thank you. So all that remains for me to do now is thank Microsoft, thank our volunteers, thank Amit and the team for putting this on, and thank you very much for the whole event. I've personally enjoyed what I've seen so far, spoke to some good people, and I hope that continues. Please get in touch with me if you want to just say hi or anything like that, and have a great day. Might be prizes to win. Have a look, have an explore. There's plenty of things going on here over the days that the conference is going. So great, thank you very much. See you later.